So in this session we will learn about Mealy state machine and Moore state machine. Okay, these two are the finite state machines, FSM. So what is a Moore state machine? In Moore state machine, output of machine depends on present state only. And in Mealy state machine, output of machine depends on present state and input. Okay, now let's consider this diagram. This diagram is related to Moore state machine. How it is related to Moore state machine? Here you can see this output is only depend on the present state of the system. This memory holds the present state. Okay, so this output is not directly dependent on input. So I can say this machine is a Moore state machine. In Moore state machine, we use three elements: next state combinational logic, memory element, and output state combinational logic. Okay, so these three elements we use in Moore state machine. Let's see the example of Moore state machine. Now this diagram is an example of Moore state machine. Let us verify is this machine is Moore machine or not. So in this diagram, this AND gate and OR gate represent the next state combinational logic. Next state logic. These two flip-flop represent the memory. And this OR gate represent the output state logic. Now, if you want to form the logical expression for Y output, that will be equal to Y is equal to QB bar or with QA. So if you examine this equation, you can see that this output is depend on only the present state of the machine. QA, QA and QB bar, right? It doesn't depend on an input A. Here A is the input, na? So this machine is a Moore state machine. Let us see the Mealy state machine. So this diagram represents the Mealy state machine. How to verify that this is a Mealy state machine? Here you can see the output is depend on input as well as the present state. Okay, so this is a diagram of Mealy state machine. Let us see the example of Mealy state machine. So this logical diagram is an example of Mealy state machine. So this is like a previous only. Here we have connected A input to this output combinational logic, right? So here I can write logical expression of output like this: QB bar or with QA or with A. So here you can see this output is depend on present state and input. So this is Mealy state machine. And let us see some example related to the Mealy and Moore state machines. So let us consider the first example. So here they are asking, construct the Mealy machine that produces one's complement of any binary input string. Okay. So what is mean by one's complement? Suppose I have a one binary number like this. Okay. How to find out the ones complement of this number? Only you have to complement each bit, right? That will be the ones complement of this number. So 1, 0, 1, 1. So this is ones complement, right? So this is the input. Now I want to construct a Mealy machine for that. So if I consider A is the initial state, okay, for example, A is the initial state. If 0 occurs, that should be complemented to 1. So if 0 is the input, 1 is the output, right? And if 1 is the input, 0 will be the output. So here this part is the input and this part is the output, and this is the state, right? So this is a state diagram of Mealy state machine. So second example is construction of the Mealy machine that prints A whenever sequence 01 is encountered in the input binary string. Okay, means if sequence is 01, output should be the A. So if I consider the initial condition is A, and if input 0 occurs, next condition will be the B. And if 1 occurs, next condition will be the C. Okay. So if pattern is 0, 1, output should be A. And other than 0, 1 pattern, I assign output should be B. Okay. Now for each state, we need to apply the different input combinations. Now consider this state A. When input is 0, next state will be the B. When input is 1, next state should be the A. And output will be the B. Right? Now in the B state, if input is 1, next state will be the C and output is A. Right? So if input is 0, next state will be the B. And output will be the B. Okay. Now at C, when input is 0, next state will be the B. And output will be the B. Right? And when 1 occurs at a C condition, we need to start over again. So next state will be the A. So input is 1, output is B, next state is A. So let us verify some input pattern here. 0, 1, 0, 1. We need to detect 0, 1 pattern here in this input. So initial condition is what? A. Right? Input 0 occurs. What is the next condition? B. What is the output? B, right? Now, when present condition is B, input is 1, next condition will be the C, and output will be the A. Now, present condition is C, input is 0, right? What is the next condition? B. And what is the output? B. Now the present condition is B, input is 1. What will be the next condition? C. And output is what? A. Right? So we have verified whenever 0 1 pattern occurs, output will be the A. Right? Now let us consider the example for Mealy machine. So example 1. Construct a Mealy machine that prints A whenever sequence 0 1 is occurred in any input binary string. Okay. So whenever 0 1 occurs in an input string, output should be the A, right? So if the initial state is A and if input is 0, next state will be the B. If input is 1 here, next state will be the C. Okay. And as we know, in Mealy machine, output depends on the present state. So let us assign the outputs. So whenever pattern 0 1 occurs, output should be the A, right? So for C state, output should be the A, right? Now other than C state, I will assign output to the state B. Okay. Now let us apply the different input combination at each state. If input is 1 at state A, next state will be A only. So at state B, if input is 0, next state will be the B only. At state C, if input is 0, next state will be B. And if input is 1, we need to start over again. So next state will be the 1. Right? So here, let us apply some pattern to verify this Mealy machine. So I am applying the same pattern 0 1 0 1. Initial state is A, so output is B, right? Now when input 0 occurs, next state will be the B. And what is the output? B. Okay, in present state is a B. If input is 1, next state will be the C. And what is the output? A. Similarly, when present state is a C, input is 0, what will be the next state? B. What will be the output? B. Present state is a B, input is 1, so what is the next state? C. And what is the output? A, right? So 0 1 0 1 pattern get detected. When 0 1 pattern occurs, output is A, right? So in such a way, we can verify this Mealy machine. The next example of Mealy machine. Now here we need to construct the Mealy machine that counts the occurrence of sequence ABB in any input string over the AB, right? So we need to find out the sequence ABB, right? Whenever that occurs, we can assign output as a 1. So if my initial state is A, if A occurs, next state will be the B. If B occurs, next state will be the C. Again B occurs, next state will be the D. So I can assign output to the stages 0, 0, 0, and 1. right? Now we need to apply a different. Now there are two different symbols, right? A and B. So we need to apply those different symbols at each input state. Okay, at each state. So when B occurs at initial state A, next state will be A only. A only. Okay. So at state B, if A occurs as an input, next state will be the B. At state C, if input A occurs, next state will be the B. Now at state D, if input is A, then next state will be B. Okay, and if input is B, then next state will be so let us verify some pattern here. Initial state is A, output is 0. Now when A occurs, next state will be the B and output is 0. Where B occurs, next state will be the C and output will be the 0. At state C, when B occurs, next state will be the D and output will be the 1. Similarly, when A occurs at state D, next state will be the B, output is 0. When B occurs, next state will be the C, output will be the 0. And when B occurs, next state will be the D, output will be the 1. So in such a way, we have constructed this Mealy machine. Okay, whenever this pattern get detected, we make the output 1. And after detecting the ones, we will count those ones. Okay, in such a way, we can count the number of occurrence of pattern A, B,